Okay, now we try to discuss about the neural network architecture. Okay, once the neuroscience find out the equations there, means that we can model the neural network in form of this one. Okay, in some textbook, this single circles there is also known as a knot, or you can also call as a neurons. Okay, then how actually the we try to designs or try to make an analogy of human brain from that neurons. Okay, from that neuron, how actually we can simplify the behavior of human brain, which is consists of a network of neurons, and we try to draw this artificial neural network architecture. Okay, we start with a single layer perceptron. In this picture, it shows that what we call as a single layer perceptron. If you can see that why they call it a single layer perceptron is because you only have single layer here. Okay, the layer, and this layer, because this layer is the final layer before you can get the output there. Of course, this is not Y, this should be Y hit. I'm sorry about the notations there. So once the layer produce the final output, that is also known as a output layer or layer outputs there. Okay, so but in some textbook, this part, which is consists of the input X here, is also considered as another layer, meaning that in some textbook it should be like this. This is also called as the input layer, and this is the output layer. But of course, why they call, if you talk about layer, you have two layers there, not one. Okay, but why still they call it a single layer perceptron is because the one that is meaningful and that consists of neuron is this layer. Okay, this one you don't have any neuron. It's actually just a direct input x1 x2 going towards the next layer. Okay, that's why they call it a single layer perceptron, because the layer which consists of a neuron is only this one, the output layers, which is a one layer only, even there's a two layer here. So that's why they call it a single layer perceptron. So I don't want you to confuse with if you refer to another source, then they call this one as an input layer, this one as an output layer. But normally, in general, we don't count this layer as a layer because it not consists. Okay, it's not as a layer because they don't have neurons there. Okay, these are direct information. X1 going toward this link, this X2 going into this line, X3 going to that line. So there's no neurons there. The one that have a neuron is at the output layer, which is a single layer there. So that's why they call it a single layer perceptron, because you only have a single layer there. So here again, if you talk about this one, just remember, if there is a neuron inside that layer, it can be represented in two functions there. Inside this neuron you have two functions. One is the input function, which is I represent by these symbols. Sorry. Okay, summation. Okay, it's a summation, and then the other one is activated function. Activation function, where I use a symbol F. So for each neuron, inside this, of course this is single layer perceptron, you only have a single neuron at the output layer. So in other words, so if you want to find the y head, okay, of course this one, it should be y head, it should be the equal of your f function. Okay, normally the output of activation function we are using v there. Okay, normally we are using v in previous lecture, and then our v there is equal to the summation of our w, I and xi. And of course normally we in many diagram or many textbook, they don't draw, actually there should be another points there. Okay, there's another points come from the bias b, and the b there give the input 1, so it's 1 times b, you will give b there. So it should be a summation of multiplication of x1 w1 x2 plus x2 w2 plus x3 wt until plus xz time wd and plus your b there, because your b is multiplied with 1, so it should be equal to the summation of wi xi plus b. Okay. However, in some textbook, they in some sources or some textbook, if you go through this artificial neural network, sometimes they want to simplify, they just set here this part, okay, this part they set as a 0. Once you set 0, then this one is not exist anymore, because this one is not exist, this one is not exist. So you can simplify your equation there. V is equal to the summation of your wi xi. So it depends. Sometimes they give you the b, because this b value normally influence in terms of how tolerance your classification is. Okay, because there is will determine how tolerance and how in terms of tolerance C of the classification, this is very beneficial in that. But you can also, to simplify your system or your classifier, you can also set your bias input equal to 0. Then now the b component is not exist anymore. Now you can simplify by getting your v, it should be just equal this with the summation of multiplication between w and x, like in this diagram. So, and another things that I will like to remember, later I will not I will not use the term v anymore. I will change this v into what we call as a net. So don't get shocked later, because when I using net is actually a v in this thing, or v in the previous lecture. Okay, just change the notation to make the notation more meaningful, because v is something not meaningful in this one. Because why I change it to net? Now if you talk about net is represent, why we use net instead of v here, because you can see that in our neurons there. Okay, let's say this is activation function, and the output for your this is your input function, and your the output of your input function is net. I use the word net. Net is actually v. Net is because they are summate, because that is represent the signal from many sites of the previous or adjacent neuron. So that's why we call it as a network result, network output. Network output come from several signal which is from the previous network. So that's why it would be better to use net there to represent all this network. this arrow there. This arrow is like a network, so all this network is going into that position, so that's why I use the word net there. And then again, the output here, I will use the term letter as the O there. So meanings that it should be the notation should be like this. To find the output of your activation, your input function here, it should be expressed in this way. Net is equal to the summation of your Wi and Xi, and then to find the output of the neuron, I don't use the Y letter because Y is for final output. Okay, final output. But for other hidden layer or other many layer there, later you will use the term O there, which represent the output of your neuron. The output of your neuron should be the F, which is the activation function, which is this one, F activation function. Okay, which is this one, activation function of your net. So it's just this one is similar, I'm using F. Okay, this one is similar, I'm using F. And then this one, still I'm using this one, the W and the X summation. Then the V you need to replace with the net. Okay, meaning that net is the output value of your linear function, and then from this output of your linear function, we go into the activation function as the input. This is your activation function, and O here is the output of the neuron, the output signal of your neuron, which is this one. Okay, which is this one. This one should be O. So that is just some notation. Later you will don't get confused, because I will use the net and the O to represent the output of the input function, which that is net. The output of the neuron, which is come from the output of the activation function, is known as a O there. Okay. So just go deep detail into this, what we call as a linear layer perceptron. So again, you can see that is the symbol. Okay, so this is the output. Of course, the output is called net. And then here, of course, in this case, because this is a linear, this is a single linear perceptron, the output here is O, then your Y head is equal to O. So that's it, because you only have a single neuron. So this is the output layer, this is the input layer, and then the input layer you have your multi-vibrated or multi-attribute or multiple feature that have been represented with this X1, X2, X3 up until XD, and then this is the wake, or this is the theta, and then the output here is something which is either 0 or 1. So in this case, what is what this single layer perceptrons behave like? What is the purpose, or what is the function of this single layer perceptron? If you can see at the output sides there, since the output is only consists either 0 or 1, so this single linear perceptrons work as a binary classifier. It's a classification and provide the Y head in term of binomial, means that it can provide 0 or 1. So it's a binary classifier, and this is the example of training data, for example, and this is the output, actual output Y. So once you key in this into this value, so of course, if you want to make sure that this single linear perceptron behave as a classifier, then what you need to do is that you can either choose your activation function it can be either what, sigmoid. You can also use unit step, and you can also use what, sync function. So these three type can make this single layer perceptron as a binary classifier. Okay, of course, this is the one we always change. This one, the input function, we don't change because it's always and forever as a linear function. Okay, it's a summation between your x and your y. And of course, again, if you talk about in some application, you also consider the bias there, and in some application you don't consider the bias there. So that's it. Okay, so that is the thing that we discussed before. The only that we change is just f, which is the activation functions. Okay, so if you use a sigmoid there, then so if you use either one of it, but of course the most popular one is a sigmoid function, then this equation over here that represented by this single neuron is actually a hyperplane function. What is the hyperplane? Remember what is hyperplane? Hyperplane is a function that represents the border that separate between class 0 and class 1. Okay, so that is the difference between regression and classification. If you talk about the classification, you are selecting f here as a non-linear, and then once you choose this f as a non-linear, such as sigmoid, sync function, or unit step function, then the equation represent in this circle is actually a hyperplane. Hyperplane is in roughly speaking is a border. Equation representing the border or the boundary that separate between class 0 and class 1. Okay, of course it's a binary, that's why you have only two classes there. But if you choose your f as identity function, then this unit is not a hyperplane or a equation that represent border. It's just a equation relate between the input x and the output y in linear manner. So that is why they call it a linear regression. Linear regression. But once you change it into non-linear, once you change the f into non-linear, then it become a linear. It will generate a linear equation, but that linear equation is not to relate between the input x and output y, but is generate the equation, a linear equation, still a linear equation, but that linear equation is a hyperplane or a equation that represent the boundary that separate between your class 0 and class 1. Okay, and again, in neural network, instead of choosing a single output like this, okay, you will find out in neural network, if you have many classes or multiple classes, it's not appropriate to represent the output as a single output like this. So you need to change the format there. Instead of using a single output like this, let's say if you want to do a single layer perceptron for multiple classes data like this, you have class 1, class 2 and class 3. You have 3 classes there. Instead of y is represented by single value or single output like this, you need to change the output into one hot encoding format. I think this one have been discovered in the previous lecture. What is meaning by one hot encoding format? If you have 3 classes of output, then you must have 3 output represented by this number, meaning that class, if you talk about class 1, it should be y1 equal to 1, y2 equal to 0, y3 equal to 0. So if you talk about class 2, y1 equal to 0, y2 equal to 1, and y3 equal to 0. If you talk about class 3, it should be y1 equal to 0, y2 equal to 0, and y3 equal to 1. So this is what is the meaning by one hot encoding format, because at one cases only one point, the rest is 0, and only single value will have 1 there. Means that if you talk about class 1, only y1 1, the rest is 0. If you talk about class 2, only y2 is 1, the rest is 0. So this is later when you want to, doesn't matter any data set. Let's say if you later if you do some assignment, if you find out that your data set is in like this, the format is like this, then if you want to apply a artificial neural network, you need to convert into this. Meaning that if you have 3 classes, then the output should be 3. If you have binary classifier, binary classifier, you will have 2 classes, then the output should be 2. So that is I think that is a standard format for artificial neural network. It's work better than applying a single format, because later you will find out that to develop a good artificial network, you should have you need to represent one class with one variable y. So means that if you have 3 classes, you need to have 3 y, y1, y2, and y3, and so on. But this is only appropriate for artificial neural network, because we don't cover other machine learning. You will find out that most of the machine learning don't use this format. For example, I think if you are using decision tree, because I also have experience, and even my student also I give some exposed to decision tree. Decision tree don't use this format. This one is only applicable for neural network. Decision tree use this format. Even support vector machine also use this format, SVM. And then what else? Bayesian classifier, not Bayesian. Yeah. K nearest neighbor, K and N, they call it K and N, also use this format. Means that most of the machine learning use this format, but this format is special for artificial neural network. They need to have this kind of format. You need to change from this format into this format if you have the data set with this format. Okay, so you can see that once you change into this one hot encoding format, now your network will become like this. Meaning that if you have 3 classes, at the output layer you will have 3 neurons. If you have n number of classes, then at the output layer you have n number of classes, or c number of classes in this notation. So that is the architecture of ANN in single layer perceptron. So here that means that again, if you talk about again, I would like to remind, every circles there will have 2 functions there. This one is input function, the output is net, and then the output of the net is going towards sorry, this is because of my tab there, I don't know why. Okay, you will have the net there, and then the net will going towards your to find as an input to your activation function here. So activation function here, the input is net, and then it will go the output is O there. So later you will see that so this should be O here, O here, O here. So doesn't matter, later we will label this neuron as 1, neuron 1, then this will become O1, O2, O3. But in this case, your O1 is equal to Y1, your O2 is equal to Y2, your O3 is equal to Y3. So that doesn't matter, because that is our output sites. And then the nets there, we will label later. This is net 1, this is net 2, this is net 3. So that's why when we talk about net 3 is referred to this the output of the input function at the neuron number 1. So that is a labeling things. Just don't get shocked when we introduce you with that notation. So just so that is the single layer perceptron. This is that now you are changing from this architecture, which consists only one neuron, into several neuron at the output layer. So why that happen? Okay, how much neuron inside this output layer is depend on how many classes, because normally if you have 3 classes, you should have 3 output there. So that's why you have y1, y2, y3. So this one become y1, y2 and y3. So again, this is net is come from the summation or the linear equation there, input function. The output function can be sigmoid function, can be sinc function, can be can also be the unit step function. And again, I just want to remind you that since the most common or the most popular activation function is sigmoid function, so later in my example, I assume all f is using a sigmoid function, but we will try to discuss several activation function. But in example or in equation or mathematical equation or hand calculation, we always use sigmoid function, because we don't want to have so many variety of activation function, and you will get blur about the concept of neural network. We want to simplify the concept, but you still know the basic step of this architecture by reduce the scope. Instead of using too much activation function, we just give you, for example, assume your f is equal to sigmoid function, so how to calculate this and that. So just to make sure that you don't scared about all the mathematic derivation there. Okay, so as you can see that once you have this kind of single layer perceptron, and then that is what we have there. You can see that of course you need to label one by one the W. Now of course previously this W is known as a theta, now it's become W. So this is W11, because this is they call it W11 because this W is a connection between the input 1 and the neuron 1 at the output layer. So this is W12. So meaning that this link or this wake is represent the link between your input x1 and neuron number 2 at the output layer. So that's how they label. Of course, if you go search to other textbook, they have a variety of how they represent this W notation. Of course, we need to find out the one that's meaningful. So now for the purpose of easy for you to understand, as well as for easy for you to trace which W is belong the W is belong to which arrow or which link. Later that is a little bit might confuse if you don't label it properly. So that's why you need to have some system to label that down. So again, this is the training data, and this is the one hot encoding format that represent this one. Okay, so you can see that once you separate, okay, what is the disadvantage of single layer perceptron if you represent in this format as compared to this format? I think this one have been learned before, if I am not mistaken. If you just have a single neuron, okay, what will happen? this single neuron can only, again, like I mentioned before, this function can represent the hyperplane, or the function that represent the boundary that separate between two classes. So that's why if you talk about a multi-class like this, just assume this is a this f is a sigmoid function. So it's like your logistic regression. So logistic regression can only or capable to separate between two functions, because of sigmoid function is a binary classifier. But if you want to solve by using a single layer perceptron, if you want to apply the same concept, but you want to apply on multi-class problem like this one, then it's not appropriate to have this kind of format. That's why you need to change it into one hot encoding. So from that one hot encodings, because of you have a three output, three output. So these three output need to represent by these three neuron. Once it's represented by these three neuron, so you have three logistic regression. This is first logistic regression, this is another logistic regression, and this is another one logistic regression. So the combination between three logistic regression, okay, if you apply this kind of data consists of three classes, this is happen, meaning that this logistic regression generate a hyperplane, or the boundary equation represent this blue line, and this orange represent this orange line, and this this one represent this line. Okay, so you can see that now by using still a single layer perceptron, you can solve, or you can develop a classifier which is a multi-class classifier. So by combined only three neuron, one neuron develop one border, or one neuron develop one boundary, then you have a three classes. Of course this one I think, yep, yeah, of course this one is a little bit confused whether this one belong to this class or this class. So because there's two lines there, but still you have three data that represent three classes, but because of you have a three neuron, which is one neuron represent logistic regression, then you can develop a three linear border, then that can separate the area that belong to class orange, the one that belong to class blue, and the one that belong to this remaining group. Okay, so that is, you can see that is the influence of changing the network there. And another things that you can learn from here, that you can see that this is the powerful of A and N. If you combine three neuron, then you can have many linear boundaries there. Imagine if you have a huge number of neuron, then you have a huge number of boundary that combine together, then it can solve the data if the data is in condition of non-linear relation between the input and the output. Okay, so that is the that is the powerful of artificial neural network as compared to this single neuron. If your data is good like this, meaning that remember during my first lecture I talk about the linear regression can only solve this thing. Yes, because this one can easily solve by single unit of neuron. But if you have, for example, you have another problems there, the blue colors there, for example, is somewhere around here, then linear regression or logistic regression is not enough to do that, because you need two line to do that. Means that you need to have another line here. So if you want two line to represent this to learn this thing, it's not enough just to have a logistic regression or a single unit of neuron. You might have more neuron to represent that. So that's why one single neuron is limited only for as a binary classifier, and that is on condition that your data or your data set have a linear pattern like this. But if you have a non-linear like this, mean this is blue and this is also blue, then it's not just enough to have one line, you need to have more line.